It was an ordinary evening. I was with a group of developers having dinner at a nice restaurant at the marina in Los Angeles. Everyone was talking shop and bantering about code. Sitting next to me was a good friend who happened to be a well-respected developer and also a published author. I was showing some of my code, and he glanced over to check it out. It was thrilling to have him interested in what I was working on. A bit later on, he casually asked me, "Why aren't you programming like you mean it?" I was rather confused and puzzled. So I asked him, "Can you explain your question?" He told me my code bothered him and said I could do better. Then he added, "I know you have studied software design and worked on some decent-sized projects. Am I right?" Of course I knew about software design. I have a degree in engineering, and I know how to program and write code. Then he repeated the question rather slowly. "Why aren't you programming like you mean it?" The language I was using back then, it was a bit primitive, but it had enough to write structured code. I had to agree with him. What I had on that paper was somewhat horrible. I was writing code that compiled, but now I could see it was missing something. That was a real moment for me. Why wasn't I writing good code? My name is Barbara Geller, and ever since that ordinary evening, I program like I mean it.
When Barbara and I first met, I had just gone back to college because I wanted to finish up my degree in computer science. I thought it would be a blast to show her some code that I was working on. She was not exactly impressed. She questioned my design, didn't like the structure of my code, and really did not care for my variable names. I was not expecting her to find any issues, and I was very offended. I felt like she was sort of insulting my work. Then she looked directly at me and said, "Why aren't you programming like you mean it?" It was not that there was anything in my way of writing decent code. I just wasn't doing it. I was not taking the project seriously, since it was just something for school. I was sure that if this code had been for a real job, I would have done it right. I knew my program worked, and that was all that mattered to me. But once she said something, I took another look at the code. I had not noticed how convoluted and messy it was. I had to ask myself, did I even know how to write decent code? I tried to argue and defend my variable naming scheme. It didn't go well. I had to admit, my code was just bad. My name is Ansel Sermersheim, and ever since that conversation, I program like I mean it.
Do you program like you mean it? Is having code which is good enough, is that acceptable to you? Do you want better than this for your code? Or is code correctness where you stop? Are you willing to acknowledge when your code might be wrong, when your data structures just make no sense? How do you handle it when some code you've written doesn't feel right to you?
If you were programming like you meant it, what would you change in your code? And are you willing to make those changes?
Programming like you mean it starts by learning the fundamentals of a computer language. We put together a list of what we believe every C++ programmer should understand. Data types are the backbone of any language, and you need to know these. Defining a class, it creates a data type. Do you know the semantics of this new type? Some people think of move semantics as just a fancy way to eliminate copies. It really is a feature for expressing the ownership of data. There are a few times when a copy is actually faster than doing a move, and that feels backwards, but it is true. Even if you are not writing templates, you need to know how they work, since you may need to debug a template error. This can happen when using something as simple as std vector. Have you considered all the places you can use const? And are you aware of where it is now required in C++ 20? People were excited when const expert was added in 11. But the committee, they keep expanding what can be done at compile time. Have you kept up with these changes? Const expert if, this can be used to replace sFine. Have you looked at refactoring your code? There are several containers, and we should know when to use a deck and when it's better than using a vector. If you are struggling too hard with the language, how will you know if your code is correct? Writing correct code requires that we keep studying and learning, since the language is a moving target. Once you have a basic knowledge of the language, now you can ask higher level questions about your code. Things like, what does it mean to be a programmer?
Now, we've all heard the stories that programming is easy. There are classes that claim anyone, regardless of skill, can learn to code in just 10 weeks. Then you automatically get a super high-paying job. In a few short weeks, you can go from almost nothing to having an app you can sell. Doesn't everyone know that once the code compiles, you're done? So why are we even asking if the code is good? We had an experience with a gentleman we were considering working with. He believed that if programming was complicated, people should ask why. We agreed with this idea. But he took it further and went on to say, the job of a programmer is to code, since the only thing that matters is for the company to make money. But he missed the fundamental point. We write software to solve a problem. If you do a good job solving that problem, the company will profit. One of his main arguments was that programmers should just hold their noses and write whatever it takes. Don't get distracted and waste time trying for perfection. To him, like so many others, programming is not that hard. And if it is, you should blame the language or the libraries. We tried to explain that programming languages are the tools we use to create software. We compared this to using a paintbrush to create an image on a blank canvas. No one looks at the Mona Lisa and says, if only I had those exact paintbrushes, I would produce art just like Leonardo da Vinci did. It would be nice if it worked this way. But we all know the magic is not in the brushes. Contrary to what he said, the thing programmers really need is training and experience. It's pretty clear we don't share some of his views. But talking with him, it was very interesting, and it challenged us. The conversation forced us to consider what is programming and what qualities make someone good at it. Of course, talent does play a role in creating good art. And maybe some things are beyond what can be taught. But we believe that one of the defining qualities of a great programmer is to be effective. Let's look at what this takes, because it is teachable.
So what does effective mean? The dictionary says, effective is when you successfully produce a desired or intended result. In comparison, efficient is about achieving a result without wasting resources. Being effective is a lot harder than just going to work and banging on the keyboard. And there are no shortcuts. How do you write code that is effective? Practice. And working with other developers who may have a different point of view. As programmers, time is valuable, and it would be nice to avoid wasting it. This would be efficient if it were possible. Working faster sounds like an obvious way to increase our efficiency. However, if our goal is 100% efficiency, then we might cut corners, or maybe use the first design that pops into our head because we're in a hurry. Does it ever make sense to sacrifice being effective in favor of efficiency? Here's an example that many projects have to deal with. Let's say a new feature has just been added to your product, and it requires some hardware upgrade, which is not practical for all your customers. It's going to take time. They can't do it right now. Some project manager actually determined that full deployment to your entire user base probably take about 3 years. Forcing your customers to take this upgrade now was not an option, or it's not practical. How are you going to support all of your customers during this transition? What if the best answer is to maintain 2 separate code bases, one for current customers and another for legacy customers? Is this actually efficient? Probably not, but it is effective, and it might be the best solution. We feel that being effective is a constant balance between correctness, quality, and productivity. I knew I wanted to be an effective programmer, but the computer language I was using was slipping in market share and not being maintained. The user base was shrinking. Developers were either leaving the language. Some actually left the industry, and they just quit programming. I was only developing software for Windows at this time, and it felt just way too limiting. I realized it was time to migrate to a new language that was cross-platform. It was 2010. And after thinking about it for a while, I decided C++, that was going to be the right choice for me. There is a huge difference between code written by a programmer who thinks in C++ versus code written by a programmer who is thinking in some other language like C and trying to translate to C++. I wanted the ability to think in C++. And to do this, it required starting from the very beginning to make sure I knew the basics. I looked around and I found a pre-11 book. Since Ansel had been using C++, he offered to hang out with me, just in case I had some questions. I started reading aloud on page 1.
About 5 pages in, I said, "Hang on. Could you repeat that? What did you just say?" I knew what a TCP three-way handshake was, and templates, those made sense to me. But what was all this fuss about data types? And why should I care? It hadn't occurred to me that I would learn anything. After all, I was simply there to keep her company. There I was, waiting to answer her novice questions about C++. And instead, I was discovering huge gaps in my knowledge. This was the beginning of our combined journey of programming in C++ and debating the definitions about everything.
Since we were already talking about code all the time, we decided, why not start a project together? At the time, I was consulting, and Ansel had a day job. This is when we started the CopperSpice project. The purpose of our work from the very beginning was to create open source libraries for C++ developers. Before we started writing any code, we sat down and debated the moral principles of open source and what problems we wanted to solve. These conversations have shaped our entire project and influenced how we work with the community. We asked ourselves lots of questions, like how flexible we were willing to be, and would flexibility be required? How do we handle contributors? We were probably going to have some. What we did not realize at the time was how powerful it was for us to keep questioning every day, are we programming like we mean it? We have had the great pleasure of being wrong more than once. Sections of code had to be tossed. Ideas had to be scrapped. And learning to laugh at bad code is still something we are working on. But we try not to toss out a design just because it seems complicated or may not be perfect. We use what we have to lead us to something better. One idea that keeps coming up for us is to make sure we consider every opportunity.
Many years ago, I had an experience at work, and I finally realized what I should have done differently. My manager at the time routinely consulted with me about project planning. He was technical, but he didn't always know the details well enough to figure out how long a given project should take. For this project, he wanted my help to figure out the monetary side, since he needed to submit a budget proposal. Estimating hardware costs was not something I did very often. I was a software person, so I sat down and I did my homework. The new project involved adding multiple servers to our existing data centers, all of which our company managed. I determined it was going to require about 40 new servers, which included around 1,000 hard drives, plus a few switches and a couple of other components. My rough estimate came out to about $1 million. And that might sound expensive, but in the context of what the customer needed, it seemed reasonable. My manager didn't react negatively to the estimate and said my numbers made sense to him. I thought things were going pretty well, and I was feeling rather pleased. An hour later, he came back and asked me, "So, what can you do for $100K?" It turns out that's all we have left in our deployment budget. The smile on my face evaporated, but I tried for humor anyway. I sarcastically told him, "Well, I can fail." This was not one of my better moments. We talked about it for a while, but neither of us knew how to proceed. The project did not go forward, and that was it. I realized very recently my actions were not effective, and I threw out a really great opportunity. Why was I telling him we could not do the project? Why did I tell my manager all I could do was fail? I should have come back with more questions. Did we really need all the hardware on day one? I could have suggested we work with the customer to find out if we could do a staged rollout or a small prototype. Now, maybe the project was doomed. I don't know. But I gave up before even asking, had we exhausted all of our options? And that was a huge mistake.
Money can be the critical resource. More often, in software, time is the commodity which is in short supply. One way to address not having enough time in the schedule is to add more programmers. Well, this will require doing some interviews, decide who to hire, then you have to do whatever training is required, and integrate the team. This is a long-term solution to a scheduling problem. It is more common to be dealing with a short-term emergency, where we ask, how do we schedule in this feature, given the team we currently have? Let's take a look at this scenario. What if you are the lead programmer and your manager says, we need this feature added, and you only have 3 weeks? After reviewing things for a bit, it becomes rather clear this will take at least double the amount of time, and you simply can't do it in 3 weeks. Unfortunately, management is not able to give you the 6 weeks that you feel you need to complete the work. So what is your reaction? How are you going to handle the situation?
Well, here are some pretty silly ideas, but they're worth mentioning since they are used a lot. You could laugh at your boss, say they're being completely ridiculous. You could complain on social media. This one is really popular. We see it a lot. You could consider working 80 hours a week and trying to get the 6 weeks worth of work done in 3 weeks. We don't advocate any of these actions. They're simply not effective. A computer friend of ours was in a slightly different scheduling dilemma. He was asked to take over a project and told it would require working holidays and weekends. As he described the project to us, he seemed proud that management was willing to give him a chance to prove himself. At his company, it was apparently customary to push employees like this to determine if they're ready for advancement. What was odd to us was they expected him to spend months working like crazy with no compensation. If you do a good job, then they might consider giving you a promotion. But this was not a guarantee, and any increase in pay was not going to be retroactive. He wasn't even worried if the company was taking advantage of him. And this is scary to us. Our fear is that this practice is common, and it should not be. A more realistic approach for how to handle the scheduling issue would be to decide what you can do in 3 weeks, since you don't have 6 weeks. I had a slightly different experience with scheduling. A while back, I was working for a company, and I realized there was a potential problem about to happen. We were broadcasting live streaming content and close to bringing up a new client. I realized they would very likely crash all our servers. Our existing system could only handle a limited number of feeds, and they were going to be broadcasting from over 50 cameras at the same time. This was not a typical client. As the lead engineer, I was extremely worried, and I decided I had to rewrite a major portion of the software, and quickly. We had a holiday weekend coming up, so I asked Barbara if she could play a bit of the managerial role and help keep me focused. She said, okay, and started asking me some questions.
So I put on my special manager hat. We talked for a bit, and he let me know there were 8 sections to the project. Okay, start a design. Do that programming thing.
So I sat down and I got started. Then I got stuck.
Hang on. Why aren't you programming? You're supposed to be writing code.
Yeah, I know, but I can't do part 3. This is going to take at least a month.
You don't have a month. Is there a way you can work around this? Maybe you can add a default. Maybe something like that will just work temporarily.
Well, I guess. Wait a minute. I know a way to bypass this, and you're right, a default is a great idea. So that's what I did. I made some trade-offs. I simplified the problem, and my code remained in production for years. It turned out we never needed the full implementation of that particular feature. And in fact, when I left the company several years later, that same code was still running.
The objective with software might be to write a game, track some data, run an automation system. Essentially, all it does is solve some problem. Ansel had discovered that the ability to broadcast a large number of streams was going to be a problem. So he modified the design and improved the code. And no hardware changes were required. Part of being an effective programmer is finding actions that you can take to overcome the obstacles. One of the problems he faced was no one had ever done a load test with multiple cameras. This oversight would have been caught in a code review, and this should have occurred long before the code was in production. So now we have found two problems. The code was inadequate, and the review process was flawed. Reviews are mandatory and should happen as the code is being written, and not the day before you're about to push to GitHub.
When you're doing a code review, the entire process consists of asking questions. One good question is, does the code solve the given problem and meet the objective? Another question you should be asking frequently is the code correct? Which means it is compliant with the C++ standard. There's no point in doing a review if the code doesn't compile or if it's broken. You do need to fix it, and you might ask someone for help, but that's not a code review. Now, there's two sides to every code review, and as a developer, you need to be skilled in both. Learn to give feedback about someone else's code, and learn to hear comments from your own colleagues.
When you're looking at code someone else wrote, be clear about your questions. If you think the code does not provide a solution to the given problem, say so. Be willing to say, I don't understand why that line of code is here. If you are too worried to ask a question out of fear of looking foolish, the process will not work. When you are not willing to speak up during the code review, you are doing both the author of the code and the project a disservice. Some people try so hard to give constructive criticism that they miss the point. The code is being reviewed, not the person. If your team is stuck tiptoeing around about how to give feedback, you will need to fix that part of the process first. In our opinion, a review is not the place to debate why the author used an if versus a switch. But maybe you do need to suggest, I see you're using an if, and why not use a const expr if? That seems like something that would actually improve the code.
On the other hand, as the author, can you explain the purpose of the code? You need to be able to do this efficiently. Be ready to provide context, because you may know something about the code the other people have forgotten because you've recently been working with those sections of code. You need to understand that some of your code will be wrong. This is inevitable. When issues are discovered during a code review, that means the process is working.
CopperSpice started out with two build systems. We had both AutoTools and CMake. This started to get a bit annoying for everyone. So a few years back, we decided it was finally time to drop AutoTools. I decided to take on the task, and it took a few weeks to standardize our CMake files. Everyone liked the direction that things were going, and a couple of our contributors pitched in and started a code review. But there was a surprise for me I had not actually standardized everything. I missed a few things, and it bothered me. Someone casually mentioned, "Did you notice that this commit changed about 150 build files?" So, of course, we were going to find things to improve. Overall, all of the comments and the feedback, this was about the build files. There really wasn't anything personal. Exactly as it should be.
So if you were doing a code review, what would make you say, this code is beautiful? Well, choosing good variable names can be complicated, and it takes time and experience to get this right. The code needs to be readable, so your team needs to document what your standards are and then do that consistently. I want to see a curly on every if statement. We had some legacy code with curly braces on the else, but not the if. It was really hard to read. Please don't do this. Look at your comments. Do they make the code beautiful, or do they detract from the readability? As you're going through this process, you should keep in mind, code is not just read one time and then put away on a shelf. It's read by multiple people in a code review. Whoever is writing the unit test will read it again. Someone else will read it when they write the documentation. And then 3 other people will read it when they're working on fixing a bug sometime down the road. But do these items really make your code beautiful? A lot of people would say yes, but we disagree. These are the mechanical parts which make your code readable and maintainable. And they are necessary because readable and consistent code is the minimum baseline. But the qualities listed here belong to what we refer to as the technical side of programming. We think the true meaning of beautiful code goes much further than this.
We believe beautiful code is something which inspires you to learn more about the code. Designs should always be beautiful and well thought out. Code is not beautiful because it is simple or because it is complicated. We were working on some legacy code and debugging a function that was crashing. Reading the code was not complicated, but something definitely bothered us. We could not figure out why this function even existed. It was readable, but certainly not inspiring. We traced through the code, found the bug, and then changed the design, and then figured out how to make the code beautiful. This is a representation of what we think programming is all about. Asking if the code is correct includes things like, does the code compile? Does it meet the requirements and solve the objective? Is the code free of undefined behavior? If the answer to any of these is no, you need to go back and redesign the code. This left side of the diagram, this is where we use our knowledge of C++ to achieve correctness. Once the code is correct, then we ask, is it beautiful? The left side roughly equates to about 30% of the work we do. This means 70% of our effort and thought is about being a programmer. There are no set rules on this side. There are times when the code may not be beautiful. And this is when you ask, is it worth a redesign? And it may not be. Then you do move on. We understand this part is subjective, which is why programming should be considered an art.
So is there an art to testing? We had someone at a conference ask us for some help, since he knew we had experience with undefined behavior. He let us know all of his unit tests were passing, but he had discovered some undefined behavior in his code. When he corrected the code and cleaned up the UB, to his dismay, the unit tests started to fail. He was very puzzled. He was considering going back to the old code, because then at least the unit tests would pass. He said, maybe this is the kind of undefined behavior that's not dangerous, or doesn't cause the compiler to drop your code. He wanted confirmation from us about the options he had. But we pointed out that with undefined behavior in the code, the results of his unit tests could not be trusted. It was possible that with the UB present, the unit test was being elided completely and might not be testing anything. His only valid option was to correct the code and remove the UB first, then figure out why the unit tests were failing.
We ran into our own issue with unit testing. I discovered some old hand-rolled test code and figured this would be a breeze to move over to the unit test framework. It was easy to move over, but many of the new tests failed. A few of the problems were off by 1 errors, and we missed these in the hand-rolled ones. These were easy to deal with. Another issue was an off by 2 error in the implementation of a reverse iterator, which was not used very often, but for this one, we had to fix our library. The crazy one was 2 strings which had the same text, but did not compare as equal in the new unit test. In the hand-rolled test, they did compare as equal. Okay, now someone is just messing with us. It did not take long to trace this back. We had a buffer which had been initialized to 1,000 null characters. This buffer, it did contain the correct text, but it was followed by 946 nulls, which did not print in our hand-rolled test. The unit test framework compared them character by character, and it reported a failure, just as it should. This was also pretty easy to fix. We just had to trim the buffer, and the unit test started passing. We think that the moral of this story is to remember you need to code review your unit tests because they are part of the code base, which makes them important.
So what happens if we confuse the theory of programming with the art of being a programmer? There was a group of developers who were talking about building an airplane as a metaphor for the implementation and design of their software. Their base assumption looks at what mode of transportation people should use to travel across the ocean. The two options they considered are a propeller plane or a cargo ship. Their conclusion was that a propeller plane was the right choice for everyone, since it was faster than the cargo ship. They also decided that since propeller planes use older technology, customers would feel safe and want to fly on them. Now, since we need to give airlines some flexibility, they allowed customizing the seating arrangements, but nothing more. The design of the plane itself obviously should not be left up to the buyer. Now, there's nothing wrong with a propeller plane. In fact, it's the perfect choice if you're the Coast Guard, since propeller planes are very efficient at low altitudes when you're searching for someone in the water. But propeller planes are slower and make a lot of noise. Jet planes are faster. They provide a smoother ride, and they happen to be based on newer technology. The question of whether to use older technology versus newer technology can't simply be answered by saying older is better or newer is better. Sticking with the airplane example, the choice of how to travel is not as simple as they're assuming. We should decide on the technology by asking, what is the problem? Are we trying to build the right airplane? Or is the point to let people travel from city to city? This depends on the purpose of the trip, the distance you're traveling, how quickly do you need to get to the destination, what airport infrastructure is in place, what weather conditions are you dealing with, and of course, the needs of the passengers.
One of our considerations is having a pleasant experience while traveling, not being in a rush, and feeling comfortable. This is why we like to travel in our motorhome. There are trade-offs. We're doing the driving, and it might take a bit longer. But we can stop whenever we want, and the food is so much better. As another example, a few years ago, we were traveling in Europe, going from Berlin to a small town in Poland. We booked a flight, and it required changing planes in Munich. The trip was cumbersome and inconvenient. Once we arrived in Poland, it occurred to us, why didn't we take the train? This would have been more comfortable for us. Check-in would have been easier. We could have enjoyed the scenery, and the trip would have taken about the same amount of time. What struck us so deeply about their airplane comparison is the belief that choosing a particular engine is the defining reason their product is good. There are things they did not consider. Do passengers still like propeller planes? Or maybe your customers are only flying with you because no one else covers that route. In terms of software, is it the right business model to base your code on older technology? Do customers still like your software? And if you are stalling the move to newer technology, are you being effective? What is the cost when moving to newer technology? We should not make these decisions lightly, and changes like these need to be worth doing.
So what's the real issue here? Well, Their theory centers around the idea that it is the technology they use which makes their software so good. Let's think about this. Why would the version of C++ you're using in your code base be the deciding factor that makes it good? There's beautiful code which uses C++98, and there's also beautiful code using C++17. So that can't be the deciding factor. This is not what is preventing you from writing beautiful code. Things like templates are wonderful, but if they're not required, don't force your code to use them. However, if the limited support for constexpr is getting in your way, then you do need to seriously consider upgrading your compiler and moving to new technology. But using every new feature in C++20 does not automatically make your code interesting or inspiring. If your intent is just to fill out your C++ bingo card, then your code base will suffer from bloat and inconsistency and be extremely hard to work on. In the end, the technology you use needs to make sense in the context of your design. And what makes software beautiful is the design, not the technology that was used to implement it. In our work, we have discovered that the key to being an effective programmer consistently is inspiration. In order to program effectively, you must be working on software projects you're passionate about. Why are you working on high-frequency trading software when you really wish you were designing games? If your day job is programming medical devices, but you find yourself working with TCP/IP in your spare time, or if your real ambition is consulting, but you have a day job, what are you waiting for? These are not rhetorical questions, and they deserve honest answers.
Of course, you do need to pay the bills, and this will require an income. But you have to be careful. There is a danger here. If you feel discouraged all the time at work, then you will teach yourself bad programming habits, and they're going to be hard to break. If your job is not very exciting right now, then ask yourself, is this temporary? And be honest. There are times we all find debugging the same piece of code for days on end exhausting and rather annoying. Even if you are working on software which inspires you, some things will not be super interesting. We try to do these parts first whenever we can. Another aspect of inspiration is being aware of the people we learn from. We often see someone looking for a list of names. Tell me, who inspires you? Well, this can be flattering, but we feel it misses the key part. We would rather know, what qualities does that person have? And why do they inspire you? If I knew this, then maybe I could cultivate some of these qualities and learn how to be a better programmer.
In 2009, I was inspired to make a change. I had reached my personal limit, and my current job was just no longer interesting. I wanted to take a risk and find something in C++ that was more cutting edge and pushed my limits. Networking was always something which had intrigued me, so I looked for a job in that field. During the interview, they focused more on my programming skills rather than did I know all the little details of networking. They did ask some tough questions. It wasn't a softball interview. And this was really inspiring to me, since I could tell they cared about C++ and making sure I could write correct code. It may have been a bit daring for them to hire me, since I lacked advanced networking experience. But I was driven and motivated to learn the networking technology because the job inspired me. I had been writing software for years, but this was the job where I started to be a programmer.
Something that inspires us is doing tandem programming, which is a variation of pair programming. Traditionally, in pair programming, you will have one person who's doing the typing, while the other person is guiding the design. Then they trade places at some prearranged interval. In tandem programming, we randomly alternate who is doing the design, and the other person is responsible for doing a real-time code review. There is no set structure for us. No one is actually in charge or running the show. But if one person is silent for too long, then it stops working. One of the things we learned early on is when we keep the banter going and share some of our crazy ideas, we come up with better designs. And we find that this does lead to beautiful code. Working together requires coordination, and you also need consensus. Consensus is the result of a decision in which team members agree to support a solution, which is in the best interest of the project. Not too long ago, one of our contributors made a request and then suggested a reasonable solution. We did not believe the issue was that serious. However, everyone did agree his solution was a good idea. We decided we would work on the implementation, but something still bothered him, so we kept talking. He felt very strongly that agreeing on the solution was not actually enough. We discovered he was looking for consensus on the severity of the problem. Our team has now changed the way we communicate. First, we focus on reaching consensus to determine if there is a problem. Then we decide, is it something we want to solve? If it is worth solving, then we reach consensus on the solution. We do not want to force consensus on every decision, since that would actually be too rigid. But the simple fact that we do want to find consensus, this changes the conversation. While we were debugging a function, a block of code caught my attention. It was not related to the issue at hand, but I was worried. I was not sure what was off. I just knew there was something wrong. At first, Ansel suggested we should just come back to this later. But I insisted we do a review right then. So we walked through the code, and a few seconds later, he looked at me and said, "I'm actually glad you stopped us. This code is not okay. How do we have undefined behavior?" We immediately realized we had consensus, that there is a problem, and it was pretty obvious. We needed to stop and correct the code. What came out of this conversation is when somebody hollers 10 lines of code, this is the signal to stop, because we are looking for consensus on the question, is this an issue we need to fix today, or can it wait?
There is another aspect of working together which will apply to any team. You need to realize getting annoyed or frustrated will happen. You cannot avoid conflicts, and you shouldn't even try, because the fact that you're disagreeing about something is useful information. This is not a bug. You should stop and discuss the issue with the intention of reaching consensus. It's important during this process to practice kindness and listen to each other. If the problem is in the code, well, maybe the documentation is unclear, so the two of you are seeing different sides of the same issue. You need to work as a team to discover exactly what you're disagreeing about and get to the root of the disagreement. You must understand why there is a conflict, because nothing else will solve the conflict, and it must be solved. We want to leave you with some questions. Do you design and write the best code you possibly can, given your skill set today? Are you being a programmer, or are you just writing code? Are you willing to speak up and say, this code bothers me, even when you may have no idea why? Can you give feedback and receive comments during a code review? Have you tried pair programming? Or maybe now the idea of tandem programming sounds intriguing. Is your code both effective and beautiful?
We hope this talk has inspired you in some way to ask more questions. Think about the type of code you are writing and really consider, are you programming like you mean it?
If you're looking for more content about the theory and fundamentals of C++, we invite you to watch some of our other videos.
We would like to thank Phil Nash for putting on this wonderful conference. We hope you have enjoyed the last few days. Both of us appreciate everyone who has stayed with us through this closing keynote. We have listed our contact information, so please feel free to reach out to us. In just a moment, we will be live to answer any questions.